Hello, and welcome to my final portfolio milestone presentation for my applied data science degree from Syracuse University. My name is Pedro Bonnin. I completed my coursework in March of 2019. I chose to call my presentation from spreadsheets to pandas because it mimics very well the way that my journey into data science has taken shape. So without further ado, I'll go through a list of items that I will cover in my presentation. This would include an introduction and background um, for myself, um, a, a little bit of an overview into a framework, analytical framework that I chose to frame my course projects and learnings. Each of the steps in the awesome analytical method are listed below here: obtaining, scrubbing, exploring, modeling, validating, and interpreting. Then I'll list out the program objectives and how I achieved each one through my course projects. And I'll have some final thoughts on the next steps for me in my journey and how I feel like I am leaving this program. So first, a little bit of introduction and background on me. I have a undergrad degree in marketing, and I've been working around 8 years in data analytics, really coming up with, I wouldn't say creative methods to apply spreadsheets to linear rating analysis and advertising expenditure. And I can say that as time went on, and I read more and more articles into AI and data science, I became really interested in it. I don't have a strong background in computer science or in coding, but in that sense, before this program, I really had no exposure to programming languages outside of a little bit of some Python classes that I took right before the program started, so I wouldn't be completely out of the loop. My favorite quote here from my introduction in my paper is that as a first-time coder, my first experience with the R language in applied data science was very overwhelming. And it's just not even about learning the syntax of the language itself, but the idea that in these courses you take your own approach to the problem and you find out your own answers most of the time. A lot of Stack Overflow and a lot of hours would go into writing just a few lines of code to do something like reshaping a data frame or outputting a simple line graph. And that's really something that takes a while to get used to, especially when you become proficient in something like spreadsheets or some other type of tool. So I chose an analytical approach introduced by Mason and Wiggins, and that I was introduced to in Professor Fox's Big Data Analytics course. This goes along with the 7Cs or CRISP DM that are very popular in the community, in the data science community. To me, this model that stands for obtain, scrub, explore, model, and interpret is very intuitive, especially after going through a year and a half of data science courses. Basically, after a question has been posed, we obtain data, we clean it, we explore it, and we build an appropriate model and interpret and present results. There are other steps that go beyond this method or approach that will go into production environments and using models as APIs. But most of my coursework focused on this portion of the data science framework. So on to the first one, obtaining. Obtaining is very important, as we can't do analysis without data. Either to have the main data set after you have a question that has been posed, or to enhance data set through feature engineering, or other methods obtaining data can help us impute some missing values, or just create truly independent variables. Um, in this practice, we see in obtaining, we find practices like database queries, web scraping, REST API requests, etc., etc. The project that I chose to highlight here was my project for scripting for data analysis, a class I use mostly Python, in which I built a web scraper to try and bring in additional data to understand what drives viewership for HBO in Chile and Latin America. I used an API from a service called the Movie Database, from which I was able to bring in clean titles, a list of genres that looked like a list instead of a long string of unrelated text, and also use web scraping to take down box office information from a website called thenumbers.com. And these new features were very important in the final analysis for the project, as were like worldwide box office and user score were very important in the final model. So onwards to the next phase, the next step. The next step is scrubbing. When I was writing my paper, I encountered this funny quote from the CEO of Kaggle in an interview with The Verge, in which he says, "There's a joke that 80% of data science is cleaning the data and 20% is complaining about cleaning the data." And this is an idea that you quickly become familiar with when you get into this field, and especially me as I progress through the program. So it's not like you're not cleaning data before, but it just feels different when it's part of the data science process. In this slide, I chose to highlight my project for data warehouse, because I believe that scrubbing, mostly in the real world, unless you are building a model that explains a certain phenomena, is mostly done through ETL processes, in which you're taking data from a source system into some sort of final clean system in which you can use to do data mining or machine learning, et cetera, et cetera. So in this project, we relied on ETL and SSAS packages to get clean data from a source system. They were dummy systems, but from a source systems into a data warehouse that we could complete dashboards and Power BI dashboards and analysis on for the end user. Although that was the focus of the project, the more the focus of the project was in scrubbing that data through the ETL process and get it to the end. Although many other projects in reality, every single other project use scrubbing of some sort before I could model the data. But I think this project approach, the way that it works in the real world, a little better. Next, we go to exploring. Exploring is really what most of my job has been in the past few years. As an analyst, most of what we do is exploring, and I find it somewhat humorous that this exploring phase is just a little bit of what a data scientist does before he models the information, and it was basically the entire job of an analyst. I mentioned in my paper the idea of clickers versus coders, and being in this clicker camp, I feel like most of my job originally was exploring and descriptive analytics. For this phase, I chose to highlight my project for applied data science, since like most of the exploring phase most of the exploratory phase in my projects dealt with visualization in order to be able to interpret large data sets that don't really lend themselves well to an understanding through just looking at the data tables. And then here we see an example of geospatial analysis for applied data science, in which me and my team plotted death rates and influenza vaccination rates against the map of the U.S., so we could get an understanding where there were different incidences of death due to influenza and vaccination rates. And onwards to the next step that I called modeling. Modeling is really the crown jewel of the data scientist, and where the most new methods are coming out of, right? This step includes a myriad of techniques that are applicable to an incredibly large set of problems. And depending on said problems, we can either use statistical or algorithmic modeling to learn more about the data. These tools obviously can be applied in different ways. I like to highlight my data mining process in this step, because through using a little creativity, like we can apply some of these methods in a different way. And for my project in data mining, I thought of superheroes as baskets of superpowers. I thought it was kind of intuitive to do it that way, since I was trying to understand how these powers align with the good guy, bad guy alignment, right? So by thinking of superheroes as baskets of superpowers and organizing my data in that way, I could see what sort of superpowers and characteristics would link to being a good guy or being a bad guy. But really interesting results at the end of the day. Just a second going back here, I would say that within modeling, we obviously find a lot of classification models and regression models as well. I used regression models for most of my course projects, and classification for data mining, text mining, and big data analytics. Big data analytics really use the most classification models, in which my team and I use neural networks through Keras and decision trees, and some other classical machine learning models through sklearn, and finally what turned out to be the most important or the most accurate was the XGBoost algorithm using boosted trees. More still validating, we see that there are several methods to evaluate the performance and compare models and their respective precision on different categories. Validating is a especially hot field right now in neural networks, trying to understand how neural networks see the world. There's very interesting articles on activation atlases from the Google Brain team. But in general, and how it applied to my course projects, we mostly use the holdout sample and cross-validation to make sure that our models are able to be generalized to data that they haven't seen, which is obviously what we're always looking for. There's a good note here to make that we should always check different methods of evaluating performance, especially if you have imbalanced data sets. You can get fake accuracy, let's call it fake accuracy, since if the class is too imbalanced to one side. So it's always important to check precision, recall, and F-scores, as well as customized metrics. Like, it all really depends on what the end goal is, what the end goal of the model is. Because there's for some problems, it's more important to not make false positives, and for some models it's more important to not make false negatives. We don't want to put people in jail, and we don't want to tell people that they don't have cancer when they have cancer, for example. And interpreting, as the last step of the OSAM framework, is really intrinsically linked with the choice of model and desired outcome. As I explained in the slide, we see here Benedict Cumberbatch decrypting Nazi code in the movie in the background. But basically, the idea here is that regardless of the application, interpretation is hugely important in getting buy-in from stakeholders. It does us no good to be able to present a black box model that nobody can understand. And this really goes hand in hand with what you choose as your model. I state in my paper that, for example, statistical models can be explained in depth. We can use Monte Carlo and Bayesian estimation to really understand how a sample represents a population, and we can use measures of fit like AIC scores and R-square scores to understand how well the models are fitting the data and what the data is really saying. But then we have other tools like a convolutional neural network, for example, which has been traditionally a black box. So these are all things to take into account when we're interpreting our models, and it's important to be able to communicate to a range of professionals as a data scientist. In conclusion, I want to go through the programming objectives for the Applied Data Science program and kind of get and show you an idea of how each of my projects dealt with these goals. The first goal is to be able to describe a broad overview of the major practices in data science. I think this is more of an overall completion of the program, like through completion of the program and all the learning that I have been able to do. I have put forth a diverse set of projects that include scripting, visualization, and other methods like associating rule mining, text mining, topic models, statistical and algorithmic models that have allowed me to really take a next step in understanding data and understanding how to apply it to a problem, to really understand what goes on behind it. And this, as a second objective, we see collect and organize data through the use of web scraping and for scripting and data analysis, and SQL databases and data administration concepts, and ETL designs and MOLAP development and data warehouse. We talk here about being able, about that obtaining phase in which it's very important to be able to get the data that you need in order to do analysis. And in here, I talk about, I highlight these projects to show how I can collect data from the internet through web scraping, for example, and store it using either SQL or NoSQL databases. And eventually, as more of a production side of environment, I have shown the ability to design SSAS packages for ETL and to design MOLAP cubes for ultimate end user presentation in a Power BI dashboard. As a third point, we have identified patterns in data, and here we see visualization and geospatial analysis, as well as data mining and classification algorithms. In general, this was part of almost all the projects that I completed for the program. Big data analytics used a lot of visualization since the data sets were very large. Applied data science, like our project itself, my team and mine project itself was mostly about the visualization and the usage of ggplot2 instead of the modeling, which at that point in the program we were a little bit new on. And I also write here association rule mining and classification algorithms for my projects and data mining, classifying superheroes as good or bad, or understanding the association between their powers and their good or bad alignment. And my project for text mining that used that brought in reviews from Google Play and the App Store to understand how different streaming services, how the reviews for different streaming services like Netflix, HBO Go, and Hulu were affected by the reviews, or what in general were the topics of the reviews for good, bad. In the fourth step here, we see develop alternative strategies based on the data. And here I really focused on developing an alternative strategy as I went through the analysis, more so than in the end application itself. So just because as an academic course project, that step in the final implementation will technically always be missing unless it was a work process that I was reevaluating. So in here I highlighted, if I move my cursor a little bit, I highlighted using a tokenizer, for example, to hot encode movie genres and scripting for data analysis, not its classical use. Or also thinking of superheroes as baskets of superpowers for association rule mining, also not its classical use. So as I went through the analysis, I truly understood the data and what I wanted to do. I could develop an alternative strategy to analyze it. Almost to the next program objective, we see to develop a plan of action to implement the business decisions, like kind of to what I was talking before. And in this step, we do see that work process that I mentioned for data analysis and decision making, which I took a work process and understood the steps that were taking a long time, the inefficient steps that were taking let's call it a unneeded time, and I was able to eliminate and make a significant impact on the final time that it's taken to do the report. And also I also highlight in this for this program objective, I also highlight the key indicators for loan repayment candidates for my project in big data analytics, which we use the Prosper loan data set to identify possible default. And in the final point here, we talk about the communication skills needed to convey analysis and results to different professionals like managers, programmers, statisticians, etc. I think in general, this is again like the first point, more of a general goal objective that was met through all the coursework and all the time spent reading and understanding how do each of these methods work. And I think my projects and my papers should be relatively easy to understand through for a range of professionals. And as the final thoughts, I can say that I have come a long way, especially as the title of my presentation says, to youth from spreadsheets to pandas. I have gathered knowledge of different tools and languages for data analysis. I have created a strong desire to keep getting better and to keep reading and getting to know new methods. I'll throw in another example here and during the big analytics class, we we got exposed to profit for time series analysis, and I think it was mind blowing how something could come out of nowhere, and could be so easily applied, and so with such great results. I would say that the program has given me a strong base across the toolbox of the data scientist. I know a lot of packages. I know a lot of packages. I have written a lot of code that I've been able to reuse in my day-to-day work. But I still think my strong suit is basically the one that it was before, which would be in uh, in um, in 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 exploratory data analysis and reshaping of data and ETL. Only now I can do it through scripting, which obviously allows me to do a lot more and a lot faster. But my next steps should be to expand on my knowledge of deep learning, one of the hottest fields in data science right now, if not probably the hottest, and as well as distributed methodologies and production environments. I would really like to be proficient in Spark, and to have a better knowledge of Hadoop and distributed methodologies, as this seems to be what the industry is moving towards. So I thank you very much. I really enjoyed the program and all of your classes, and hopefully we'll see you down the road. Thank you.